Well, hello. I am Jaedyn Hoenig from Young Women in Southern California, and I am one of their regional ambassadors. And today I'm interviewing Dr. Ana Porras. And the first question I have is, can you just share a bit about yourself and your background and how you got into what you currently do?
Yes. Hi, Jaden. It's really fun to be here with you today. So I am Ana Maria Porras. I was born and raised in Bucaramanga, Colombia. So I am not originally from the United States.
Mm.
And I actually moved here to study what I do now, which is I'm a biomedical engineer. So growing up, I knew I liked science, I knew I liked biology, and I knew I liked engineering. My parents were engineers.
Mm-hmm.
Um, but I just like couldn't see myself doing, I don't know, cars or bridges or things that
Yes.
are
Yep.
dead.
I feel the same way.
Yeah,
Same exact.
I just
Yes.
like I just like couldn't see myself doing that. And I didn't actually know that you could be an engineer that worked in things that were alive. It wasn't until right after I graduated high school that my mom went to another university different from the one where she used to teach. And she learned about bioengineering. And so then she came back and she was like super excited. I did some Googling and I learned that biomedical engineering existed.
Mm-hmm.
And that's how I got like interested in the field to begin with.
Nice. Okay, well, that's beautiful. I'm super interested in biomedical engineering, so I have all types of questions.
Awesome.
Um, but so could you kind of walk me through your professional background and your educational background that kind of led you to the position you're currently at right now?
Yeah, of course. So, like I said, I wanted to study biomedical engineering. So, this was back in 2005. So, this field in general is really young. Like here in the United States, most programs are like at most 20, 25 years old, which is
Mm-hmm.
really, I know to young people now, it doesn't sound that young, I mean, but it's a new field. And at the time in Colombia, in my home country, only maybe two or three schools had a biomedical engineering program.
Mm-hmm.
And so then my parents and I kind of collectively decided that it would be better for my education if I came to the United States. And so that's why I actually came here in the first place.
Mm-hmm.
So I came and I did my undergraduate degree at the University of Texas in Austin. And then after I finished that, I was still really interested in biomedical engineering and I just wanted to keep doing research and learning more about a specific area of biomedical engineering called tissue engineering. So then after that, I moved to the University of Wisconsin to do a PhD in that. And then after I finished that, I decided that I loved biomedical engineering. I loved tissue engineering, but everything that had learned about was more like problems that affect people in the United States and Europe.
Mm-hmm.
And so I was really, because I'm from Colombia, I was really interested in other topics that had more like global implications.
Yes, understood.
And
Much understood.
through like a really, really, really long story, I ended up here at Cornell University in the state of New York, where I now study the gut microbiome. So it's like I never imagined that I would end up studying microbes,
But here you are.
but here I am.
And shifting more now to kind of what you do now, could you tell me a little bit about the research that you're doing at Cornell?
Yeah. Yeah. So one of the things that I am really interested in right now, the reason really that I came to this lab is so we have microbes that live inside of us as humans, right? Specifically in our guts. So in our intestines, they're full of a ton of different microbes.
Mm-hmm.
And you've probably know this because maybe you've seen it in the news a ton, like your microbiome. And if you eat this, your microbiome is going to change. But one thing that people sometimes don't know is that a lot of what we do know about the microbiome, we know only from studies that we have done in populations in the United States and Europe. And we know a lot less about the microbiomes of people who live in other parts of the world.
Okay.
Yeah, and so since I am one of those people who is from other parts of the world, I'm really interested in understanding how those differences at the like country level impact our human health. So what we do is we have partners in different parts of the world. So specifically, I've been working with samples from Guatemala, the Fiji Islands, and here in the United States.
Mm-hmm.
And then we can transplant those samples of like the human microbiome into these mice that we have in the lab that don't have any microbes. And so we can humanize them so they
Right.
become like American, Fijian, or Guatemalan. And then I can try to feed them say, like, sometimes, when you go to Chipotle and there's contaminated lettuce and then you get sick. So then I try to infect the mice.
Yeah.
And I can take a look and see, what ends up happening actually is that the Fijian mice get sicker and the Guatemalan mice barely get sick.
Oh,
Like
that's really
they're
interesting.
more resistant. So kind of understanding how those differences impact the host, so the organism that has all of these bacteria, and like what effects that has on your immune system.
In your position, kind of, could you describe like your basic job activities and like what you go through in a typical day in the lab?
So usually my day involves a meeting or two, research, and the kind of research most of us do nowadays is very interdisciplinary and very complex. So usually I have at least one meeting with a collaborator or maybe with a lab mate that's helping me with something, with undergraduate students that work with me. So you usually have at least one meeting. I try to do most of my lab work, especially now that we're like COVID, when you actually have to very specifically and intentionally plan your day in the lab.
Mm-hmm.
So I try to get most of my lab work done here in the morning. And so that usually means I have to grow some bacteria or maybe grow some human cells. So I do that for a few hours and then I go home, and then I have to sit down at the computer for the rest of the day, maybe the second half of the day, and analyze some data or maybe write up some results, write some code. And so then I would say right now it's about 50% me being in the lab like I am now, and 50% doing stuff on the computer at home.
And so what would you say is your favorite thing about working in your position, and then one of the most challenging things about working in your position?
Yeah. Something that I've really liked about this position that I'm hoping to take into the next one is I love just the ability to travel to different parts of the world and interact with so many different people as we do this science. And like, especially I feel like in this project, I do see myself reflected in the project itself. So that has been my favorite thing. And the most challenging thing is, like I was saying earlier, I am not trained in microbes. So it has been a pretty steep learning curve. And I'm still learning every day. So definitely the most challenging thing is like sometimes I'm like, I really have no idea. And then I have to go figure it out.
And then kind of bridging off of that, what would you say are some of the most important technical or soft skills for somebody who would want to work in your position?
Oh, that's a good question. For technical skills, I really wish I had learned to program when I was your age, even like a little bit, not even a ton. Like I think that would have made me less scared to take on some of the projects that I am taking on now. That I would say is like my number one advice to younger people as far as technical skills. And then as far as soft skills go, super important to learn how to work in a team and how to communicate, both communicate like with your teammates, but then also how to communicate your results. Because in science, like if you can do a bunch of cool stuff in your lab, but if you don't know how to communicate it to the rest of the scientific community and to the rest of the public, then it kind of stays in your lab and doesn't really go anywhere.